Hello everyone, we are from Group 2. As you can see, there are 10 members in our group. The topic of our presentation is PBL-based lesson plans for the Module 9 in Grade 5 Science. In our today's presentation, it covers 5 parts as you can see on the screen. Part 1, Introduction. Firstly, I want to talk about objectives of attitudes and values. This module is part of the content for the 5th grade of primary school, the first semester. The main theme is light. This module exposes the fundamental properties of light, including its sources, propagation, reflection, refraction, and color. We apply PBL, problem-based learning, teaching method in our lesson plan. As you can see, the content of lesson plans are developed into the 10 plans as you can see. Number 1, exploring the world of night by investigating night sources and phenomena in daily life. Number 2, examine the path of night to understand its streamline propagation. Number 3, uncovering the mystery of shadows by analyzing the dynamic relationship between light and shadow. Number 4, revealing the magic mirrors through the study of night reflection and its applications. Number 5, investigating the blending of the night through water to explore refraction. Number 6, discovering the transformation of night through everyday examples of reflection and refraction. Number 7, understanding the formation of rainbows by exploring the phenomenon of light dispersion. Number 8, decoding the color secrets of objects by examining the relationship between color and light. Number 9, designing and creating practical inventions that make use of light's properties. Number 10, showcasing and refining our scientific practice in a final light and shadow project exhibition.
I will introduce Part 2, Module Learning Objectives. Objectives of knowledge and understanding. Learners will be able to distinguish between neutral and artificial light sources, explain the rectilinear propagation of light, and describe the formation and variation of shadows. They will comprehend fundamental optical principles, including reflection using mirrors and refraction through lenses and water interfaces. Students will also understand the scientific basis of rainbow information through light dispersion and explain how the color of objects relates to light absorption and reflection processes. Objectives of skills and applications. Students will gain hands-on experience by conducting experiments to observe light phenomena such as constructing pinhole cameras and investigating shadow dynamics. They will apply their knowledge to design and create simple optical devices like periscopes and kaleidoscopes. Cultivate students' collaborative problem-solving skills through problem-based learning tasks. These tasks will enhance students' ability to solve problems related to light. Objectives of attitudes and values. Students will nurture their scientific curiosity by exploring new natural light phenomena and develop an appreciation for light's essential role in technological advancements in everyday life. Through group experiments and tasks, learners will enhance their teamwork abilities, communication skills, and collaborative spirit, fostering a positive learning environment where they can share discoveries and insights about the fascinating world of light.
Okay, let's move to the part 3, the keys and challenges of lesson plan. In this part, we have 4 key points of teaching. The first is mastering the rectilinear propagation of light and its verification methods. And the second is understanding the fundamental principles of replication and refraction. And the third is explaining common optical phenomena in daily life. And the fourth is developing scientific inquiry skills and experimental techniques. And we also have 4 challenges of teaching. And the first is understanding and visualizing light refraction principles. And the second is differentiating between refraction, and scattering. And the third is comprehending the relationship between disappearing and color mixing. And the last is applying optical principles to practical scenarios. So this is the part 3, and let's move to the part 4, the teaching methods in lesson plan. And in this part, as we can see, the application of PBL in lesson plan. And first, the module adopts a problem-based learning approach, engaging students in various problem-solving activities to promote a deep understanding of light concept. And the second, we can see the problem-based learning opportunities allow students to apply their knowledge creatively. The PBL teaching method is a problem-oriented teaching approach that is based on real-world scenarios and is a student-centered education approach. Under the guidance of the teacher, it is student-centered and problem-based, and through the form of group discussion, students independently collect information, identify problems, solve problems, and cultivate students' autonomous learning ability and innovation ability. And the third is thought-provoking question, like why do shadows change size and how do mammals flip images? Stimulate student curiosity. As is lost is a cooperative learning strategies are woven throughout the module, with students working in groups to conduct investigation.
Now, let's move on to part 5, teaching highlights. We selected 2 lessons to demonstrate. Now, let's look at Lesson 1. Lesson 1, Discovering the World of Night, Exploring Night Sources and Night Phenomena in Life. Lesson 1 is designed to spark students' curiosity about night by exploring its sources and real-world phenomena. This 40-minute lesson aligns with the curriculum standard of distinguish between natural and artificial night sources, and using evidence to support the concept that night comes from the source. In the pre-lesson stage, we begin with an engaging real-world scenario. A family is preparing for a typhoon that may cause a power outage. What night sources should they prepare? Students are shown 3 emergency kit scenario cards featuring a solar lamp, a kerosene lamp, and a glow stick. We pose the inquiring question, which is the best choice and why? This encourages critical thinking and sets the stage for exploring night sources. Next, wild lesson stage. This lesson unfolds with an exciting activity called Night Seeker's Quest. Using a PowerPoint, we flashes images of various objects like the sun, night bulbs, fireflies, and traffic signals. Students participate in a quick-fire showdown, raising night or not night signs to identify true night sources, making learning interactive and fun. Next, students work in groups on a practical task, designing the best emergency night kit for family during blackout. Each group receives a physical night source, such as candle, fluorescent stick, or flashlight, and completes an observation sheet noting characteristics like color, brightness, and electricity leads. They discuss their findings and decide which kit is most effective, fostering collaboration and inquiry. Finally, groups share their conclusions in a concise two-sentence presentation about their light source, reinforcing communication skills. Next, that is the post-lesson stage. To wrap up, the class collaboratively creates a light source family mind map on poster, visually organizing their findings. For a real-world extension, students are tasked with the findings and photographing 3 new light sources at home to share in the next section, connecting classroom learning to everyday life. As for the teaching highlights of the lesson 1, this lesson emphasizes student-centered learning through problem-based learning by engaging students with a readable scenario, interactive games, and hands-on group tasks. We cultivate scientific curiosity and teamwork. The activities are designed to help students meet the learning objectives, listing at least 5 common light sources using key terms like a light source and image light on observation sheets, and establishing the concept that light comes from the source.
Hello everyone, it's my turn to introduce lesson 2. In this slide, we are going to explore the street light propagation characteristics of light. And in this slide, we are going to know some basic information about our lesson plan. For example, the curriculum standard, the learning objectives, the teaching materials and resources. And then let's come to get more basic information about our lesson plan. In this slide, we are going to divide into 3 parts. The first part, prepare students by reviewing light sources and raising an inquiry question through an animation. For example, can light bend around corners? The second part, focus on hands-on experiments using punched card, a maze, and a laser pointer. Students discover that light can only reach an object when it travels in a straight, unobstructed line. They also record and share their observations. The final part concludes with a class discussion on whether light can bend and connect the findings to the scientific concept. A real-world extension encourages students to observe flashlight bends at light, reinforcing the idea that light travels in a straight line. Okay, this is all of our presentation. Thank you.